in talking about graphs, domains, and ranges, you may have heard domains and range before, but maybe not interval notation. Um, and this is an important concept. So let's say I have a value x here, right? And so x is going to be less than 5, but greater than or equal to 3. Instead of writing it like this, we can use interval notation, meaning we write it almost like a point. So this notation here, we'd write like this. It looks confusing, but basically it's saying that this value of x goes from 3 to 5, anywhere from 3 to 5. This parenthesis means that the 5 is not in the set. So it means it goes up to 4.9, 4.999, 4.99999, but never 5. Whereas this bracket, this means that 3 is in the set. It's the same thing as this, right? X is greater than or equal to 3, meaning x could equal 3. But x is strictly less than 5, meaning it goes up to 5. You can see 5. You can almost feel 5, but it never touches 5. It never equals 5. So that's all interval notation is. Now, if we bring this into domain and range, remember, domain, these are the x values of a function. The range are the y values of a function. So if I have this function here, function of y is equal to y plus 3, instead of thinking about what domain could be, and this is a little bit tricky because here the x values are technically y's. For number 2, the x's are k's, and for 3, the x's are n's. So the x values meaning the inputs, and the y values meaning the outputs. So the domain here, in this case, what this y can be, instead of saying, well, what can y be, start with what y can't be. What can't y equal? Here, hopefully we realize that this is just a straight line. Is there anything that we can't plug into this function? No. So that means it goes from negative infinity to positive infinity. So using interval notation, we write it as this. Now notice I put parentheses here because you can never touch infinity. You can never get to infinity. So whenever you have an infinity, whether positive or negative, using interval notation, it's always going to be parentheses, never brackets. And the range is similarly, what could the outputs be for a line? Again, it's going to be negative infinity, positive infinity. It's going to go on forever. Now here, hopefully we can see that this is a parabola because it has a degree 2. It's a quadratic, which means it's a parabola. So the graph's going to look like this. Domain, what could the input be? Well, it could be anything to the right, to the left. So again, the domain is going to be negative infinity to positive infinity. There's no value of k that you cannot plug into this function. You can plug in anything you want. Now, are you necessarily going to get everything you want? Well, no, because this is a parabola. This point right here, that's the minimum, which for parabolas we also call the vertex. So to find the vertex of a parabola, the formula for the x value is negative b over 2a, which in this case is negative 4 over 2 times 2, which is negative 1. That's the input value, though. I need the g of k, the output value. And so in order to look at that, what I need to do is to plug this negative 1 back into the function. So 2 of negative 1 squared plus 4 times negative 1 minus 6. Well, this gives me 2 times 1 squared, which is 2, plus negative 4 minus 6. 2 minus 10 is negative 8. So the lowest value is going to be this negative 8. So it's going to start at negative 8, and it's going to go up to positive infinity. I put the brackets there again because it actually equals negative 8. If I plug in negative 8, if I plug in negative 1, I get a value of negative 8. But there's no way that you can get anything less than negative 8 by plugging in any value of k. And finally, this is a square root. So, what can you plug in here for n? You can't plug in anything that would make this square root a negative because you can't take the square root of a negative. So this 2n minus 8 must be greater than or equal to 0. And we're going to solve for this. So I get 2n is greater than or equal to 8. So n is greater than or equal to 4. If I plug in 4, I get 2 times 4, which is 8, minus 8 is 0. The square root of 0 is 0, and that's fine. However, if I plug in 3, I get the square root of negative 2. That doesn't exist. I can't have that in my graph. So that's why the domain here, my input values, it's going to start with a negative 4. And because I have this greater than or equal to, it's going to be 4, and anything greater than that. I can plug in 1,000,000 into this, and I get 2,000,000 minus 8. That's fine. I can take the square root of that. It may not be an integer value, but it's still a real value, and that's great. Now this is going to impact my range, my outputs. Now here, if I plug in 4, which is the smallest value in my domain, I get 0. So that's going to be the smallest value in my range. And that's going to go on forever, right? Again, because if I plug in 1,000,000, I'm going to get the square root of 2,000,000 minus 8. That's a lot bigger than 0. I'm never going to take the square root of this and get anything less than 0. So that's why my range starts at 0. That's domain and range. These are some difficult examples. When we start doing some more practice in class, we'll do some linear problems. Graphing also helps. So if you need to graph these, take a look at those graphs. But this is key. And also the interval notation. So you're still a little shaky about interval notation. Definitely focus on that with the more simple problems, and then come back and revisit these more difficult examples. I think. Yeah, we'll come back to increasing and decreasing functions in just a second. For here, let's find the domains. Again, domains here, I'm not asking for ranges, only the domains. So what can I plug in? This first function actually these first 3 are the functions we just did. So I'm going to start with number 4. Number 4, it's another square root. You can't take the square root of a negative number. So that means that 9 minus 3t must be greater than or equal to 0. So if I subtract 9 from both sides, I get negative 3t. It's greater than or equal to negative 9. And then I divide both sides by negative 3. When I have this inequality and I divide by a negative, I switch the sign. So instead of it being greater than or equal to, it's now less than or equal to. So I have t is going to be less than or equal to 3. And so if I write that as interval notation, that's going to be everything less than 3. So that's negative infinity all the way up to 3 and including 3. And I can test this by plugging this in. If I plug in 3 into this, you get 9 minus 9, which is 0. The square root of 0 is fine. So that's the answer to number 4. Number 5, you have to, again, think about what I can't plug in. What can't this be? This function here for number 5 is a fraction. Fractions can be negative, they can be positive, but the denominator can never equal 0. So that means that 2x plus 4 cannot equal 0. So I solve for what x can't be. So if I subtract 4 from both sides, I get 2x cannot equal -4. So x cannot equal -2. And it makes sense. If I plug in -2, I get 2 times -2, which is -4, plus 4 is 0. That's a 0 in the denominator. That's a red flag. So when we have something like this, where x cannot equal -2, we think about the smallest value. The smallest value here is -infinity, and it goes on until we get to -2. Now we're going to put parentheses here or brackets. Put parentheses because this actually, it can't equal -2. And then I pick up again at -2, and it goes on forever. Now I put this u in here between these two sets to show it's a union. It means both. Unions and intersections, this is very complex. I'm just going to touch the tip of the iceberg on that and leave it alone. We need this for interval notation. In future math courses, you may see this, you will see this used more frequently. All you need to know for this class is that if you have two groups of parentheses or brackets, just put a U in between them. It means union, it means both. All right, number 6. I have this right here. This looks trickier than it is. We have another fraction. So remember, this fraction cannot have a 0 in the denominator. So r minus 1 cannot equal 0. I don't really care about this first r. I would only care about that if I'm talking about the range, but I'm only talking about the domain. Actually, hold off on that. So r cannot equal 1. Because if r equals 1, then I have this denominator being 0. So the smallest value I can have is -infinity, and it goes all the way up to this value being 1. Now, what about when r is 0? Well, then I have 0 plus -1, which is -1. When it's +2, I have, so when r is 1, I have that the value overall, when r is 0, I have that the value overall is -1. When I have that r is 2, I have that the value overall is 2 plus 1/2. 2 plus 1, which is 3. Notice there's a substantial gap there. And that's going to impact the range. But for us, for the domain, we only care about what we can plug in. It goes -1 all the way up to 1. Again, this union, 1 to infinity. Number 7. Yeah, 7's a good one. Because it looks trickier than it is. This denominator cannot equal 0. That means w squared cannot equal -1. Well, wait a minute. If I take a number and I square it, can it be negative? No. So this denominator here is always going to be positive, which is great. That means that our domain is -infinity to +infinity. It can be anything. You can take any value you want and plug it in here. This denominator will never be 0, which means that the fraction, the function overall, works. Number 8, this square root here, that's in the denominator, so it can't be 0. So square root of x plus 3 cannot equal 0. So that means if I square both sides, x plus 3 cannot equal 0. Um, and so x cannot equal -3. However, because it's a square root, I can't have that be negative either, because then I have some imaginary number in my denominator. So rather than me saying this is strictly not equal to 0, I'm going to say that this x plus 3 must be greater than 0. That means that x must be greater than -3. Before, when we had a square root, like in number 4, we said it could be greater than or equal to. But here, we know it can't be equal to 0, so it's just going to be greater than. So this means that instead of a bracket, I'm going to put a parenthesis. So -3 to positive infinity. And that's my answer for number 8. And number 9, we have this. Again, being underneath a square root means that this needs to be positive or 0. Now this right here, this has a star because this is a difficult one. 8 also had a star, but hopefully it wasn't too difficult. It's tricky, but not too difficult. This involves quadratics, right? So we're going to have that v squared minus 2v minus 8 is greater than or equal to 0. What we actually need to do here is we need to factor or use the quadratic formula. Sorry, that's a plus 2. So we could actually factor here. So this is going to be a v plus 4 and a v minus 2. It's going to be greater than or equal to 0. So v plus 4 is going to be greater than or equal to 0, and v minus 2 is going to be greater than or equal to 0. So v is going to be greater than or equal to -4. V is going to be greater than or equal to +2. So this shows us that v is going to be greater than -4 and also greater than -2. So we would write it like this. We would write it greater than 2, greater than -4. I think did I make a mistake somewhere? So if I plug in the -4, it works. Oh, sorry, this should be less than or equal to. Less than or equal to 0, but less than or equal to -4. So what we get is we're going to have negative infinity to -4, and then union. Whoops, I need my brackets because I can equal. So everything less than -4, including -4, and also 2 to positive infinity. And so those are my answers there in interval notation. I will say this, especially the last 3, those are more difficult than we're going to have in class. But if you can follow along, then you're in really good shape. Otherwise, the first 3, the next 3, I won't be asking many difficult questions about this. But as long as you understand interval notation and how we get the domain arranged, then you're doing well with this. We can also get these from the graphs. So we want to find the domain and range from these graphs. And looking at this, I did change this a little bit. So I actually had some y values here, and that seems to not have saved. So for this right now, we'll kind of go through it. So here for part A, the domain, this is going to be what could exist for the input for the x values. It's parabola, so we could see there is no x value that can't be plugged in, so the domain is negative infinity to positive infinity. The range, this goes up to 3, and stop. I don't have anything greater than 3. So the smallest value is negative infinity, and it goes up to 3. That's the end. For B, so that's A. For B, the domain, what can x be? It starts at negative 2. Now this open circle, if you remember graphing, this open circle means it actually doesn't equal it. So that gets a parenthesis, and it goes all the way over here to whatever this value of x is. This dot means it stops. So if I say, oh, I don't know, this is 10, then it goes to 10 and stop. And yes, I will give you actual values. Again, I did put those on here, but it must not have saved. The range for number B, letter B, again, the y values. So here we start at 0, but it doesn't actually equal 0. So we get this parenthesis, and it goes up to y is equal to 2. Keep C over here. C, the domain, just like letter A, it's not a parabola, but it looks similar. Any x value can be plugged in here, any input. So that's negative infinity to positive infinity. And the range, smallest value is going to be negative infinity, because this arrow means it goes on forever. So I come up here, it goes up, hits 8, and equals 8, and it gets a bracket. So those are my answers for the first 3. For number 2 here, number 2. I think I just, whatever. Right, so for D, what we want to do here is we want to find the domain. What can the x value be? Well, here we see we start at negative 3, and it equals it. And it goes all the way to 0, and equals that, but then it skips. And so we have another set. We pick up at 1, and we go to 3, and we're done. The range for this is going to be from 0. It does actually equal 0. So that gives a bracket. And then if we say that this value here is 1, it goes up to 1. And it does equal, so it gets another bracket. E, the domain, aren't actually any values here. So if I say, oh, this is negative 5 and this is positive 5, it starts at negative 5. So I get a bracket because it does equal, it has a closed circle. And it goes all the way until positive 5, but an open circle, meaning it doesn't actually equal 5. So I get a parenthesis. The range is going to be from negative 1 to positive 1. But here we can see it actually equals negative 1, so that's a bracket. And then with the open circle at the end, it gets a parenthesis. F is a tricky one here, the domain. Domain, this actually goes up and up and up and up forever, but it doesn't actually equal 0. And you can see with this function, they actually give us a function there, which I circled hardly. If you think about it algebraically, x can't equal 0 because that's going to be undefined. It's 0 in the denominator. So the domain is going to be negative infinity to 0, parenthesis because it can't equal it, and then from 0 to infinity, right? Picks up right off from 0. The range, very similar. We can see that we have that same behavior on the y-axis, or sorry, the x-axis. We will learn later on this is called an asymptote, but for right now, we don't need to be too concerned about this. So this goes from negative infinity to 0 in union 0 to positive infinity. So trying to pick these up from graphs can be tricky. I did go through this fairly quickly. You will have points, you will have simpler graphs. Just make sure you understand the concept. Again, interval notation, domain, and range. What can the inputs be? What can the outputs be? Now, we also have this concept of increasing and decreasing functions. So here I have this graph. And where is it increasing? Increasing for graphs means y is increasing as x increases. So as I go from left to right, basically the graph is going up. So here I can see it's going up until this point, and then it goes down. And then from here, it actually goes up again. So where is it increasing? Well, from negative infinity to this x value. Please note it's the x value, not the y value. So from negative infinity to negative 2, and then again from negative 1 all the way up to positive infinity. Now, with this interval notation, note I put parentheses here, not brackets. And that's because at the point negative 2, it's actually not increasing or decreasing. Take an object such as a ball, throw it up in the air. At the highest point, what is it doing? Is it moving up or moving down? If you got a super slow motion camera or try to envision it, you can actually see for a brief millisecond, it's not doing anything. It's completely stopped. It's stationary. And that's what's happening at these points. So it's at negative 2 and negative 1. It's actually not... Oh, sorry, I did the y value. Whoops, I did what I said not to do. That's a 0. So at negative 2 and 0, it's actually not increasing. It's not decreasing. It's just doing nothing. It's not moving. So we exclude it from these intervals. Now, for decreasing, it's as the graph is going down. And that's from everything in between. So from negative 2 to 0. Now this is a nice graph, and you can see how basically we go increasing, decreasing, increasing. This endpoint matches with this starting point, and this endpoint matches with that starting point. So nice overlapping. Doesn't always happen that way, but it's something that can help you check. All right, last thing, I swear, it's a busy day here. Relative maximum, relative minimum. If I asked you what's the absolute maximum of this function here, there actually is none, because this goes on forever, 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 forever in both directions. So, some mathematical typing here. Basically, all this says is that there's going to be a relative minimum where it's the smallest point that is within a certain interval. So here, so for here, where does it look like is the smallest point? It's actually right here. And this is a point. Now note, this is not interval notation. These are coordinates. So the relative minimum here is 0, negative 1. Because we're going down, we're decreasing, and then we change to increasing. That's the relative minimum. Whereas the relative maximum is where we're changing from increasing to decreasing. We get these little peaks and valleys. And this point is negative 2, 3. Relative maximum, relative minimum. We wouldn't say that this point is a relative max, because it's higher than this. Well, what about this? What about this? We say that this is a relative maximum because it's a turning point. So when you're looking for these relative values, think about turning points. For this right here, estimate, you would use your graphing calculator. And we will be doing that. We will be looking at that and figuring that out. So actually, I tell you what, why don't I load that up and go through that right now. So if we're going to look at this, negative x cubed plus x, we're going to find on our calculator the relative minima, the relative maximum. So, if I have my calculator here, I'm going to get rid of everything I was working on previously. There we go. All right, so y equals, I plug this into the y equals function. And I look at my graph. So there you can see, I'm going to change the window just around a little bit because obviously we can see that the minimum maximum are in there somewhere. So I'm actually going to change my window. The x minimum, I'm going to change to -2 and the x maximum to a +2. And, you know, they both look like they're less between -1 for y and +1 for y. So I'm going to change my y min and my y max to -1, +1. And just by changing the window, we can get a better look at this graph. To find the minimum and the maximum, there's actually a function in the calc version here. So I go second, trace, and look at that, minimum. So I choose minimum and ask for a left bound. I'm looking for the minimum right now. So visually, I have to see that it looks like it's about here. So I have to move this left bound to some point to the left of where it looks like. So this is definitely to the left. I hit enter. I ask for a right bound. I move it somewhere to the right. Hit enter. I ask for a guess. I don't care. I usually just hit enter again. And there we go. So my minimum here would be -0.577 and comma -3.85. And I could do the same thing for the maximum. So I won't do that. I'll leave that to you. I'll have the answers up here so you can check. But really, the most important thing from this section right now is understanding interval notation. If you can find minimum, maximum, great. Domain and range is very important as well, but that interval notation is the most important. So we'll be spending lots of time on this in class, and so make sure you have any questions ready for class.